Welcome, welcome. Hey, Punzi. Um, Heartfelt welcome to everyone coming in. I would like to take a moment to um, welcome any new guests that are new to our webinars. We're really happy to see you here and hope you get a lot of value out of the soil webinar today. All right, we're gonna just give it probably a minute more for letting people in. This was our first time boosting the webinar on LinkedIn, so I think that sent the reach out a little further, which is great. We are
The hot
we are
topic.
very international today. I am coming to you from Palm Springs, California, where I am at the Esri Technology Summit. Um, WildNote has completely embraced integration of mapping into our platform. We currently have the ability to create polygons and lines and points on iOS and plan to increase that to Android. You can still do points on Android, but plan to get that implemented on Android this year. And I'm just down here learning more geospatial concepts, how to build a better web interface and better integration between ArcGIS Online and ArcGIS Pro to WildNote. So I am from Palm Springs. I hope things go well. I'm on my cell phone hotspot. And so is Nancy coming to us from where, Nancy?
San Miguel de Allende in Mexico. If you haven't been here, boy, I highly recommend it. What a charming community this is. And I'm also on my hotspot. So, if we depart, it's all about you, Phil, which is really what people are here for anyway. So we'll be all right.
That's right. Phil's got us. So where are you coming to us from, Phil?
I am in Portland, Oregon, where it is raining lightly, which is sort of typical for this time
Okay.
of year.
Right. Nice. Okay, well, I think I will now I'm watching other folks come in. This is great, and I will get us started. Okay, hello, and welcome everyone. It's great to be back for our 32nd episode of our Lunch and Learn series. We are here
33rd,
today with
33rd.
a new friend of ours, Phil Scoles. 33rd, 32nd, 33rd. I'm reading the script, as you can tell. 33rd. Thank you. We are here today with Phil Scoles of the Wetland Training Institute and principal of Terra Science. We hope you ask questions. Go ahead and do that through the chat. Receive value and walk away with real solutions to real problems. I am Kristen Hazard, founder and CEO of WildNote. My co-host today is Nancy Douglas. She's all about making our customers happy, Director of Customer Success. And I'll introduce Phil now. He is the principal of Terra Science, an earth science consulting firm specializing in wetland delineation, hydric soil evaluation, wetland hydrology assessment, permitting, mitigation, and addressing complex wetland issues. With extensive experience in hydric soils and wetland hydrology, he serves as an instructor for the Wetland Training Institute, imparting his knowledge to professionals in the field. Additionally, Phil contributes to the environmental professional program at Portland State University, sharing his expertise in soil science and restoration. We had the privilege of joining Phil on 2 wetland training days and have learned firsthand how difficult it is to identify soils. So, we're working on getting the soil suggestions into the platform. And so Phil's been kind enough to train us on how to understand that so we can code it up for the platform. And this is a quote from Phil, I guess. I guess Nancy remembers this. I don't remember it. Hydric soils are more cryptic than a Jackson Pollock painting. Did you say that, Phil?
Yeah, you said that on our last call.
Yeah, I did.
That's funny. So we're going to bypass our stories from the field and get right to it, our problem solve segment, because we got a lot to go through today. So we're really just trying to solve the problem of how to identify hydric soils in the field. And, when we were out with Phil the first time, He surprised us by saying, I believe 90% of the time you will have one of the Fab Four soils. So, Bill, want to get us started on a discussion of soils and specifically the Fab Four soils?
Yeah, so I will start with a little bit of background. The hydric soil indicators were put together by the National Technical Committee on Hydric Soils starting around 2000. And this was in response to a National Academy of Sciences a report that was done in the late 90s that said that the hydric soil indicators in the 87 manual were a little bit too broad and they needed to be regionalized. So they worked very aggressively, in the early 2000s to come up with different hydric soil indicators. And so ultimately, they came up with sort of some broader concepts for hydric soils. And there's a category of hydric soils in the field indicators of hydric soil that are organic soils and
Mhm.
things like a histosol or a muck layer or something like that. Those are like the A1, 2, and 3 indicators. They also came up with mineral soils that have a depleted or glade matrix. That's like the A11 and the A12 and F3 indicators. I'll go into some of that a little bit later on. They also had another category of mineral soils that are darker and they have redox concentrations at like models of sort of the old terminology, and that's things like the F3 and F6 indicators and S5. And then they had some additional kinds of mineral soils that were just maybe just dark soils that didn't necessarily have redox concentrations in them. And then there was another category of stuff that's sort of catch-all of lots of sort of oddball kinds of things. We often call those boutique indicators because they're only being applied to a relatively small geographic area. And then there's
Mhm.
another category altogether for Alaska, and Alaska has different hydric soil indicators
Mhm.
that are mostly based on hue and less on things like dark or gray colors, because dark and gray colors are often the colors of ground up rock. And Alaska was once upon a time just a bunch of ice grinding on the rocks. And so much of their uplands have these gray or dark soils. So they came up with some different indicators
Mhm.
for those. So, with that being said, Kristen is correct in saying that there are four hydric soil indicators that we see more than anything else. Now, maybe where I work a lot in the western part of the United States, it seems like it's 90% of the time that I find these four hydric soil indicators. If you're in other areas that have sort of a different kind of climatic condition, like you're down there in the southeast part of the United States, like Florida, the Gulf Coast areas, you tend to have slightly different kind of soil situation. So maybe it's not 90%, maybe it's only 80% or 70%. Still, you see
Mhm.
particular four indicators more than we see just about all the others combined. So
Bill, have you delineated in every single region?
not delineated. I have taught classes in all of the regions, which means I've done a lot of digging around in the dirt and describing stuff, but actually performing delineations. My experience is mostly in the West Coast, Oregon, California, Washington. Probably done one or two in Nevada, something like that, where I'm actually doing the whole 9 yards.
Got it.
Good question. So so what I wanted to do is go over the concepts of these, four hydric soil indicators that we see more often than not, because the more individuals get familiar with these are, I think it makes it a lot easier and takes out a lot of the mystery of trying to decide what hydric soil indicators are there. And let me rephrase that a different way, which is that sometimes when people are delineating a wetland, it's like this doesn't seem to match a particular indicator. And the first thing I would say is go back and look at these particular and see if it take a second look at that and look at all the little details in the language and see if in fact that would make a difference or that is one of those. So with that being said, I think I'll jump right into the F3 indicator if that's okay, unless there's
Yep.
questions. So the
Perfect.
the F3 indicator is an indicator that applies to um, soils that are loamy or clay. And I'm going to bring up a slide here that's got some of this stuff on it. So bear with me while I figure out how to get some of these slide shares done. Um,
Okay.
Looking for a particular diagram, which I'm not immediately finding. Oh, I think I know why. Uh, Hold on for a
So
minute.
while Phil's doing that, just want to share a little bit of the poll results. And in particular, I was interested in what people were going to identify as the biggest challenge in identifying hydric soils. And for our folks that are on this call, distinguishing indicators in difficult field conditions is 62%. 51% deciphering and applying the soil indicator definitions. So that's where the tricky bits are. Identifying the correct color of the soil, which was the hardest thing for me and maybe for you too, Kristen, when we were out there. It's only 20%. So people have kind of got that part down, it sounds like, with this group. But it's really around.
What would difficult, wonder what difficult field conditions means, like it's pouring down rain or it's super hot and I'm just miserable, or what? If someone could pop in the
Could throw that in
chat.
the chat. Yeah.
Well, bad weather does have a tendency to dull our cognitive abilities. So
Hmm.
make something difficult. But I think what they're getting at difficult often is when one or more of the three parameters is disturbed or altered enough that it's confusing. And so
Right.
difficult would be that you're trying to delineate part of a mowed lawn and you don't have any sort of plant clues because it's all just turf.
Mm,
Yeah.
So
got it.
our grazed pasture is another good classic example. So the diagram that's up here, I think most folks have seen, is for determining the soil texture. And we do that every time we're describing the soil. But what's important to understand, and hopefully you can sort of see my cursor, little hand here, going around the textural triangle. And the F3 indicator is for all of these textures that are the vast majority of the textural triangle, but not these two textures in the very bottom left-hand corner. So, and that's true for all the F indicators. The S indicators, standing for sand, are these two textures, sand and loamy sand. And the A indicators are for all the textures, it's regardless of the texture. So F3 is applying to anything that's sandy loam or finer. So things like silt loam, clay loam, or clay. And it's worth sort of mentioning that for those folks that have practiced doing soil textures, what is a sandy or what is a fine to clay kind of texture is something that it could feel sandy, but you can make a ribbon with it after you sort of moisten up the soil. If you are moistening up the soil and you can't ribbon it, then where the soil is just sort of falling off your fingers, there's not enough fines in the soil. That would probably be in the loamy sand or sand category.
Hmm.
So the the F3 indicator, let me go to let's see if this will show up here. Does this is a handout, and will this handout be available to folks?
Yeah, we'll be sending this handout to everybody who has signed up for the webinar after this.
Terrific. So the F3 indicator, this is a summary of the F3 indicator right here. And it says here that it's a medium to light gray matrix value where it has a value of 4 or greater, chroma 2 or less, with 2% or more redox concentrations. And that's a summary because there's scenarios out there where we don't have to have redox concentrations, and I'll get to that. But it says that you have to have a depleted matrix. A depleted matrix is one of these concepts that has been very difficult for people to sort of understand, but it's really fundamental. And that's why I'm going to go back to this diagram here that people have seen, it's in the regional supplements, and they've probably seen it in field indicators of hydric soil. But it basically says that if you have a value 4 or higher and a chroma of 2 or less, then that's what we would call a depleted matrix. It doesn't have to be on the 10YR page. It could be on any of the standard pages, but not the Gley page. And I'll get to that in a moment or two. That if it has a value of 4.1 and chroma of 4, I'm sorry, rephrase that. A value of 4, chroma 1, or 4.2 or 5.2, it has to have 2% or more distinct or prominent redox concentrations. If it's a value 5.1 or 6.1 or higher, it could have redox features, but it's not required. The fundamental thing about it is it's a chroma 2 or less, and it's medium to light gray color. And so that's the depleted matrix concept. When we go back to the description here, it has to be a depleted or matrix, and it has to have a minimum thickness of 2 inches or more that starts at 4 inches from the surface, or it has to be a 6 inch layer that starts at or less than 10 inches. And for those that are still learning a little bit about the field indicators of hydric soil, there's lots of these equal and more than or equal and less than throughout the field indicators. And it's super important to be paying attention to those because lots of folks might misread it and say it has to start at 10 inches when it's no, it could start at 4 inches. It just has to be 6 inches thick from that 4 inches down to, say, 10 inches. So this depleted matrix concept, is real fundamental. And F3 is, I wouldn't say it's the most familiar. I'd say it's the second most familiar indicator that we come across. But it has this concept of being gray to light gray with redox concentrations in it. And we find it in all kinds of wetlands out there. Vernal pools, for those that are working with that type of wetland, it's one of the most common hydric soil indicators used with that situation.
So
So
what's depleted and what's the matrix?
So depleted means that if you were to go back in time, a couple thousand years, you would see that the original alluvium or parent material maybe was something that was yellowish brown or brown or something like that. But over time, when it's been exposed to saturated and anaerobic and then reduced conditions, the iron gets stripped from the matrix and reconsolidated into the redox concentrations, or what happens a lot of the time, the iron gets stripped, put into the soil water, and wherever the soil water goes, that iron goes with it. So over time, what you would see is a brown soil that gets grayer and grayer and grayer until there's essentially no available iron left in the soil.
Okay.
And
Yeah.
that's what depleted means. It's depleted of iron.
Right.
So, and the matrix is just sort of the background color of the soil. If we were looking at, a picture of, you just think about any particular kind of soil that you've evaluated, it's sort of the predominant soil color. There's a few situations out there where sometimes there's less matrix than there is redox features, but that's very unusual. So let me go to a picture of the depleted matrix here, and go back to my screen share and find. All right, so this would be a fairly classic. Very classic example of a depleted matrix where you can see that this is that gray color. It's got a little bit of a brown tint to it, and that's understandable. That means there's still a little bit of iron in that soil. And then when we look at this and see if I can zoom in a little bit, not get too grainy here, you can see that there's lots of redox concentrations, and all of this iron used to be in this part of the soil, but when it went from anaerobic to aerobic, the iron precipitated in various pores and open spaces sort of in the soil. Let's see if I got another example of a depleted matrix. Not in this one.
While you do that, I actually misspoke. If you guys could do questions in the Q&A, that's actually the right spot. I misspoke and said chat. So
Oh,
Yeah, chat's live too, so it's if there's other
that's
besides
fine. Yeah, but
questions,
we can kind of track it in the Q&A. So
yeah.
yeah. So this would be, this soil here would be another example of a depleted matrix and the redox concentrations.
okay.
So The term depleted sometimes is used as a redox feature, and that's right in here, right around this root is a depletion. And
Yeah.
you can see that more of the iron has been stripped out of this area and not reprecipitated. And that's because you've got
Hmm.
essentially a carbon source, which is a root that's making
Yeah.
it reduced for a longer period of time. But depletion
Hmm.
and depleted matrix are technically different terms. And depleted matrix refers to the whole thing, meaning that all the soil as a matrix color, and a depletion is referring to just a discrete spot in the soil matrix. All right,
Okay.
so let's jump back to the let's stop my
So we have
share
a
here.
question that's relevant to that. For a depleted matrix, is it then possible to meet this indicator with the first 2 inches of soil?
Yes, so the let me go back to that my this this diagram here. So this is the Fab Four sheet here. It says here there's two options. One of them is it's a 2-inch layer that starts within 4 inches of the surface, or a 6-inch thick layer that starts at 10 inches. So if you have a 2-inch layer that's right at the surface, then the 0 to 2 meets that requirement. If it starts right at 4 inches and then goes down to 6 inches, it's also meeting part A. But as soon as that your layer is starting below 4 inches, like say it starts at 5 inches, it would have to be a 6-inch thick layer to meet
Okay.
the F3 indicator.
Yep.
Right. So that's F3, a very common indicator. And that this whole concept of a depleted matrix is what is part of the A11 indicator. And the A11 indicator is an F3 uh, situation potentially, but it has a dark layer above it. And so, for example, it says here in the description, it's a dark topsoil with an underlying gray matrix with redox concentrations. It's a layer with a depleted or glazed matrix with 60% of the matrix is value 4 more, or chroma 2 or less, and has to start at 12 inches within 12 inches of the surface. So what's important to understand is that this depleted below a dark surface A11 indicator is it's allowing the depleted matrix to start deeper in the soil than is allowed for the F3 indicator.
Hmm.
So a lot of times when I am, digging my soil pit, and I notice it's a dark soil, it's like, well, okay, this could very much be one of these indicators that uses a dark surface color requirement. And I keep digging and digging. It's like, wow, I'm down, almost a foot now. And finally it breaks into a grayer kind of soil. It's like, well, then this is probably going to be the A11 indicator, because I notice I'm just digging deeper to get to that gray layer. So this,
Hmm.
as an indicator goes, is saying that it has to have this dark surface above. So the fine print, when you read through the field indicators of hydric soil, it says that the organic loamy or clay layers above the depleted matrix has to have a value of 3 or less, chroma 2 or less, and it has to start at less than 6 inches from the surface. What's unique about this indicator is that it's requiring that this dark surface has to be right on top of the depleted. If there was a layer in between the depleted matrix layer and the dark surface layer, then that would violate the requirement, and it wouldn't be met. So
Okay.
uh, and that's pretty important that they're being that kind of precise. And
Hmm.
let me sort of take a sidebar here about precision, which is that when they developed these hydric soil indicators, they were being very precise. And so if they say that this indicator has to be the like with the A11 has to have that depleted matrix start at 12 inches or less, and you encounter it beginning at 13, it's like that indicator's not met. It's not a close enough kind of situation. In fact, there's another indicator that allows for a depleted matrix starting below 12 inches, and that's the A12. So when they are being specific, there's a reason why. And when they field tested all of these hydric soil indicators, they went around to a lot of places throughout the United States to make sure that their precision was reliable.
Phil, what
So
would be,
This is a good
or
question. Sorry, Nancy. Yeah.
oh, go ahead, Chris.
So, related to that, related to the surfaces being right next to each other, what would the ecological processes be if we have a layer between the depleted matrix and the dark surface?
So a classic situation is that lots of soils out there, if you dig deep enough, will have a depleted matrix. Even an upland soil, if you go down, 3 or 4 feet, in the right circumstances, it could have a depleted matrix. So that's just basically the height of the seasonal, water table. And so we would, there's plenty of situations where we have a dark soil at the surface or dark layer at the surface, and then you get into a brown or gray layer, but no redox features. Uh, and then you keep digging, and eventually you get to a depleted matrix. So that interceding layer could simply be just upland material and evidence that the water table is not getting closer to the surface. And also, just sort of when you're just outside the wetland boundary, you're seeing that maybe get a few feet higher in elevation, and you're seeing the soils, evolving. That there's more, that there's more upland kind of conditions in the soil, and the depleted matrix keeps getting deeper and deeper. Does that help answer that question?
Hopefully so. Let's keep moving because we're
Yeah, I talk a lot.
closing
So
in. It's great. You're a great teacher.
Okay, so that's depleted matrix. I'm sorry, that's the A11 indicator. So one of the things you notice with the depleted matrix concept is the requirement that it have to have a chroma of 2 or less. So that takes us over to sandy redox. And sandy redox, the S5 indicator, is going to be for soils that have textures of sand and loamy fine sand. And it's actually a very simple indicator. Once you deduce that you have a sand or loamy sand texture, it simply says that you have to have a layer that's at least 6 inches, or a layer that starts at 6 inches less from the surface, that has a matrix of 60% of chroma 2 or less and 2% redox features that are distinct or prominent as soft masses or pore linings. In other words, it's a chroma 2 or less soil that has redox features in it that begin at 6 inches or less from the surface. This one requires it to be a 4 inch thick layer, but what they've ultimately said is they're not going to be restricted to a depleted matrix concept that uses a value of 4 or higher. It's any value in chroma 2 or less. So again, when I'm digging a soil pit, if I notice that as I'm digging into the soil, one, if it's a sandy soil, it's going to be a lot easier to dig through. That I'm looking in that upper 6 inches for redox features, and I'm looking for it to be, potentially gray enough. And if I, am digging into a soil and it's like, yeah, this is looking sort of yellowish brown or even brown, and no redox features, it's like, I don't think this is going to meet S5.
Mhm.
That's usually my thought process as I'm digging the soil. Is this likely to be meeting, one of these Fab Four indicators?
If
So
this is sandy, does that mean it's too sandy to make a soil ribbon even?
that's correct. So when we're doing that soil texture, we have to moisten up the soil to do the soil texturing. And usually when we try to make a ribbon, it just, we're basically pushing it out from our fingers and it just falls apart.
Yeah.
So this one has a fairly low threshold of 2% redox concentrations. And but with sandy soils, what you have is parent material that is more uh, quartz and bedrock kind of material that's ground up, and less surfaces for chemical reactions to happen. So they have a lower
Mm.
threshold for the amount of redox that's on there. So
Hmm.
that's yeah. So moving on. Well, let me just before I finish up here on sandy redox. If you're on the coastal plain on the East Coast, all the way down into Florida and Georgia, you are going to see the sandy redox feature or indicator a lot. Now, wherever it's that coastal plain, that's one of the predominant colors or indicators down there.
Okay.
The last indicator is the F6 indicator, which at least, been my experience, in the West Coast and maybe in the Midwest, the Great Plains area, we see this indicator the most. And it is similar to the sandy redox in that it requires to have a chroma 2 or less. But in this case, they're restricting it to a value of 3 or less. So when when you look at, let me go back to this this page here. You know, the depleted matrix uses these chips here. The dark surface uses these down here. I often tell
Hmm.
people, when I teach a class, draw a box around these ones here and write the word dark surface. And when you see these
Hmm.
on any of the pages, that's when they use that phrase dark surface, we're talking about those chips in the lower left-hand corner.
Okay.
Good tip.
Yeah.
Yeah, that's a good
So
one.
it has to be a value 3 or less from a 2 or less, and has to be a 4-inch thick layer that starts at or less than 8 inches. And then with a chroma 1, it has to have 2% redox concentrations that are distinct or prominent. Or if it's a chroma 2, it has to have 5% or more redox concentrations that are distinct or prominent. So let me just go to a picture or so of this
Kurt,
redox.
Kurt Kleist had
Yes.
a comment. He said, sandy matrix, we often have soils with a mixture of clay and sand along disturbed areas, which make sandy redox or redox dark indicators.
I got to read that comment again here.
That's in the chat.
Yeah.
Difficult, says, makes it difficult.
Yeah. So this gets back to, we have at the beginning of describing the soils, we have to look at the different layers. And so these indicators are applied per layer. So if you had a soil that had a sandy surface and then it went loamy to the next layer, then went back to the sandy layers at the bottom of the pit, you would have to use the S indicators for the top and bottom layers. But the middle layer, you'd end up using either the A indicators or the F indicators.
Mm.
So this is an example of an F6 indicator. For those that are looking at it, it's like, where's the redox features in here? And the redox features, I'm going to try to zoom in a little bit on this. If you look closely, you start seeing it takes a while to sort of focus your eye on that color, but there's a dark reddish brown in here.
Mm-hmm.
And
Yeah, I
once you
can
see
see
it
it.
down here, then all of a sudden you see it over here, and you're seeing a little bit over here, and it's up in here, and even some up here,
Yep.
and seeing up here and there. So one of the things about the F6 indicator, is especially as the soils are really, really dark, is that you sort of have to calibrate your eye. And I usually do this by on maybe an area that doesn't have redox features, like right in here, sort of stare at that for 5 or 10 seconds, and then I let my eye migrate over to here. It's like, oh, I can see that reddish brown.
Mm-hmm.
And so sometimes it's teaching your brain that these sort of subtle colors that initially seem to blend into the background are actually there, and they're in much higher concentration than your first glance. So it's one thing is just don't rush into doing the redox features. I always say do the matrix color first, sort of the dull colors first, and then migrate over to the redox features. And while you're doing the dark colors, you start to see where the redox is actually showing up in the soil. So going back to the diagram.
You ever
Or
rotate it around at all, Phil, to try to kind of
oh
get a
oh
different view?
Yeah, all the time. That's super critical is don't limit yourself to just the first sort of glance at the soil. That sample that I had a picture up there, I break that open
Hmm.
several times before I
Okay.
actually decide on my color and redox to make sure that I'm giving it a fair chance. So
Yeah, got it.
six is real common, and I generally recommend to folks memorize this indicator. Just let it become part of your normal, routine. There's probably 50 plants that I know off the top of my head. I always know their indicator status because I see them enough that I don't want to have to look them up. And this
Yeah.
is what I would say for soils is memorize F6. If you're down there in sandy part of Florida and a coastal plain, maybe you should be memorizing the S5 indicator.
Okay.
So I know we're running a little bit low here. Do you want to do questions, or should I jump
Yeah.
into
Yeah. Let's
stuff
do
about?
some questions here.
Yeah.
Um, I'm going to try to get this one right because it was edited. Is it true, based on the indicator of hydric soils 9.0, that if there is a 6 inch of a soil color that is a 2 chroma with no redox and there is a depleted matrix begins below 6 inches, the soil cannot meet F3 or F6?
So they have some interesting wording in the last version of field indicators of hydric soil that's a lot different than what they had in version 8.2. And we're asking right now why they made these changes here, because in the F6 indicate what they're getting at with that statement, they just didn't, when they reworded it, they didn't really do a good job. So apologies to
Okay.
some of those folks. What they're ultimately saying is you have to have, or you're not allowed to have a layer that's 6 inches or greater that is chroma 3 or higher in the soil profile above what we call the diagnostic layer. So in other words, if you had a 7-inch layer of 10YR 3/3 at the surface, and then you had a depleted matrix that would meet the F3 indicator, you are not meeting that indicator because fundamentally you have to have a the layers have to be all chroma 2 or less, or anything that's chroma 3 has to be less than 6 inches. I'm sure that
Hmm.
the way I just phrased it didn't clear it up for folks. What they're trying to get at is that it's often an upland soil when you have more than 6 inches of a chroma 3 or greater in a soil, even if you have redox features or depleted matrix deeper in the profile.
Hmm. Another question, where can we find the source of all the data and studies that led to these precise soil indicator specifications?
I don't know about a specific, repository of the field results, but if you go to the NRCS webpage for the National Technical Committee on Hydric Soils, they have all of their minutes from their meetings from the last, I don't know, 10 or 12 years up on there. And
Hmm.
you get to see their deliberations about particular indicators and some of the stuff that they're working on and stuff like that. I think they came up with the original concepts and then they delegated to a bunch of soil scientists at the NRCS to go out and field check these things wherever they, were encountering them. But I don't know if
Hmm.
there is a master sort of study that they did that they could say, here's all of these different locations and so on. I would say from a
Okay.
practical experience, I have found these indicators to be highly reliable and
Okay.
rarely get a false positive out of them.
Okay. It looks like Kurt Kleist may have put a link to that. I haven't clicked on it yet, but in our chat, he put a link. Maybe that answers that question. Logan Elms asks, can you review any exceptions for soils with higher salinity for these Fab Four?
Well, the exception is huge. Once you have a soil that has a pH of 7.9 or higher, iron does not like to reduce to the same degree that it does with a lower pH. So it's very common that a high pH soil that has reduced conditions for a long period of time may have a brown or yellowish brown, even an olive brown kind of color to it, but it doesn't have redox concentrations. So the Corps of Engineers recognized this when they came out with the regional supplements, and they created a problematic situation for moderately to strongly alkaline soils. And so the
Hmm.
gateway opens into this problematic situation is that you first evaluated all of the available indicators for your region. If you didn't meet one of those, and then you also met wetland hydrology and you met hydrophytic vegetation, then you enter into the problematic procedure for hydric soil. So if you have a little bit of a test kit that you can use for doing pH, and you can say, oh yeah, this is a pH 8 soil, then you read the description on problematic high pH soils, and it pretty much says confirm that it's high pH, confirm that you have the other two parameters met, and then I check other on the data sheet and call it a problematic high pH soil. So the real
Okay.
of a high pH soil is look at the plants that are growing there. At 7.9 or higher,
Uh-huh.
it starts to exclude a lot of plants. And so you start to see certain shrubs and herbaceous things that tend to only grow that have some kind of salt tolerance to them.
Right. It says here, you mentioned using a soil indicator with a particular texture and a profile. What if there is a difference, i.e., loamy clayey portion is hydric and the sandy portion is non-hydric? What is the correct determination?
So if you have, let's say you have three layers and one of those layers meets a hydric soil indicator, if the other two layers are not meeting an indicator and they're different textures, that doesn't matter. If one layer meets an indicator, then you're fine. What sometimes happens is that one layer uh, uh, doesn't meet an indicator for the thickness or the depth, and then the layer right below it, if it doesn't also meet for the indicator requirements for everything but soil depth, then it doesn't qualify as a hydric soil. There's a section in the last part of the regional supplements for soils that talks about when you can combine two layers to meet an indicator for either the depth or the thickness requirement. You can't you can't mold or you can't meld or combine two layers where one of them fails to meet a color requirement or a redox requirement or other sort of important diagnostic element to that indicator.
Mhm. Cool.
It's not a common
Um,
situation, but people run across it sooner or later when you keep digging holes.
Hey, Phil, we're gonna you kindly put together a top five best practices from Phil Scoles. Do you want to run over those really quick for the folks that are still
Sure.
hanging on with us?
Oh,
I'll just
I wrote them down somewhere, and now I don't have them right in front of me. Um, you might
I
have,
can share them right here.
yeah, if you can share them, then wait, save me some searching
Can
around.
you see those, Phil?
yep.
Uh, yeah, I just need to make it a little bit bigger for me to see. All right,
I'll
so
read the first one. Keep soil slice on shovel and decide layers first. Wetland soils often have 3 to 4 layers in the upper 16 inches, while upland soils often have 2 to 3 layers.
yeah, it's a big mistake to dig a soil pit, take a slice from it, and then dump the soil off the shovel and then start working on it. Keep it on the shovel if possible. Now, there are times when the soil is so dry you can't keep it on the shovel, but assuming
Right.
that it's moist enough, or some sandy soils are hard to keep on a shovel, but keep it together, and most importantly, do the layers on the shovel. And when it can't stay on the shovel, go to the pit itself and make an in situ determination on those soil layers, from the top of the soil surface.
All right.
So,
Now I'll jump to five, which is also about the soil pit digging. Um, so sometimes when you hit near misses, right?
mhm,
Then what's your suggestion there?
take another slice of the soil pit. We often, take a slice from one side of the pit to, put on the shovel. And what I do if I narrowly miss an indicator by 2% of the redox or 1 inch on the thickness or something, then I go to the opposite side of the pit that I did my first slice and take another slice. And if that
Hmm.
doesn't work to meet an indicator, I do it again.
Okay.
We're looking at a real small amount of real estate when we do the soil analysis. And so it's not cheating to uh, take another slice. It's looking at a larger amount of soil, and you might find that you meet an indicator that way.
Right. Number two is about like the duff or the material at the top. That doesn't count in the uh, depth, right? So your
Yeah,
zero starts under that, correct?
that's correct. So
Mhm.
There's some hydric soils out there that it's a mineral soil right to the surface, but there's lots of situations where there's a layer of duff or some thatch material that sort of has knitted itself together that makes an over-horizon. And for mineral soils, our zero measurement for meeting an indicator starts under the organic layer.
Right. We already talked about three, which is memorize F6, and then four. Once you decide on a matrix or redox color, go to the next page forward in the book and the next page back to kind of get a comparison.
Yeah, I find a lot of people sort of feel a little bit unsure about their soil color and
Yeah, I did.
did it. And the easiest way to confirm you're at the right color is to just look at slightly different hue by going one page forward or one page backwards. And it
Hmm.
helps. So just go to the same spot on the page, just
Right.
different hue.
Yeah. Okay. Any other? Nope. No more Q&A. We got some thanks, and I guess
Let me
we
share
want
my
to wrap this up,
screen.
Nance. What do you think?
Yeah, I'll share my screen with Phil's email. He said he's happy to share that with everybody here. And make sure I have the right one up.
And we'll send you some goodies. We got some good tips and
Yeah,
handouts from Phil that'll come out to the group, and then the video is always available as well
yeah, that'll
after.
that'll be out at the beginning of next week. And
Hmm.
Here's Phil's email, Scoles, remember the E on the end of Scoles at terrascience.com. So grab a screenshot of that or jot that down if you have any more specific questions. Like Kristen said, we're going to
Hmm.
send out his top tips as well as the sheet that he was using with his summary information about the Fab Four, which is great. Phil, we cannot
Yeah,
thank you enough for the time that you have taken to put this together.
yeah,
For our folks that have been on this call and who signed up for the webinar. I know it's going to be super helpful for them in the field. And
Hmm.
do
yeah.
you say anything, Phil, about upcoming classes for?
Well, I teach classes with Wetland Training Institute in Portland State. So the Wetland Training Institute stuff that's up on their website. I think it's wetlandtraining.com. And Portland State's classes are with the Environmental Professional Program. You can contact me if you were interested in one of those classes. I'm going to teach about 20 classes throughout the year. Some of them are just back to back, the same course with just a different group. Yeah, but
Right.
the other thing I would say is, since people have my email and they have your email, is if you've got other kinds of soil questions or soil topics, send us an email and we can see if we can't sort of come up with another discussion on soils or something like that. Because I definitely know from teaching a lot of classes that soils is not the kind of course that they spend a lot of time taking at college, and so they're learning their first sort of real exposure to soil details through their wetland delineation process.
We can have a soils AMA with Phil Scholes. Yeah.
Exactly, exactly.
You might find out a
Nice.
little more than you need to know about soils in that situation.
Fantastic.
All
Uh,
right. Well,
couple,
um,
I have something else, Kristen, that I just want to share. Just a reminder, quick touch on WildNote for anybody who's still on the call. It's a current customer. Latest release is project copy. So if you haven't tried that yet, give it a go. You can copy an entire project or portions of a project to make setting up your wetland projects a lot faster. And we also do have the latest version, the final version of the Rapid Ordinary High Watermark form in the library now. Just wanted to make sure everybody knew that. We're working on uh, the export for that right now, but the input side is available to you out of the WildNote libraries. Just want to make sure we got a mention in for both of those.
yeah, project copy is good for more than just wetland projects. It's good for all
Yeah, it's good
projects,
for any
actually.
project, but
Hmm.
since we've got
Yeah.
mostly wetland people on this call, I wanted to mention that.
Yeah, for sure.
Yeah.
Yeah. All right.
And then our
Well,
next,
thank you very much.
sorry, just yeah, I just also wanted to say that our next lunch and learns on eDNA. So make sure to keep an eye out for that. And that'll be next month, third Wednesday. And that's going to be a super interesting conversation as well.
Very. All right. Thanks, everyone. Have a
Thanks,
great day.
Phil. Okay, bye-bye.
Thank you, Phil. You're the best.
Yeah.